Hello everyone. So in this video we are going to solve candy problem. So there are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. Now you are giving candies to these children subjected to the following requirements. Each child must have at least one candy, and children with higher rating get more candies than their neighbors. Now we have to return the minimum number of candies you need to have to distribute the candies to the children to meet above these two conditions. Okay. So the two conditions are each child must have at least one candy and the children with higher rating get more candies than their neighbors. So let's see example 1. So in the example 1, the ratings of the childs are 1, 0 and 2. So each child must have at least one candy. So we will give first each child one candy. So let's say this child has one candy, this child has one candy and this child has one candy. Now let's see. According to the condition 2, if the child has higher rating than their neighbors, then they will get the higher candies. So the first child has higher rating than the second child. So we will give two candies to the first child. Okay, so we'll give two candies to the first child. Then the second child, we will leave it to the one only. Now the third child has higher ratings than the second child. So third child also get the two candies. Okay, so in total of 5 candies we will need minimum 5 candies. Okay, now as per example 2, we have three children with ratings of 1, 2 and 2. Now if we give all childs one candies, then you'll see that the second child has higher rating than the first child. So the second child will get one more candy. So the second child will get two candies. Now the third child has two rating which is equal to the second child's rating, but it is not greater than second child's rating or its neighbors. So the second child can get only one candy. So in total of we require minimum of 4 candies to distribute to the children as per the given conditions. Now we will solve this question in two approaches. The first approach will require extra space and the second approach will not. So let's first see the first approach. Okay, so the condition is that each child should have at least one candy, and the condition is that if a child has higher rating than its neighbor, then the child should get extra candies. Okay, so let's understand this by a graph. So let's say this is the rating graph, and so for example, if this is a child and the child has this rating, okay, this rating, then as per the condition 1, each child must have at least one candy. So we'll give each child one candy initially. So each child now has one candy. Now as per the second condition, if the child has higher rating than its neighbor, then the child should get one more candy, and we have to distribute candies in such a way that we will get the minimum candies. Okay, so now this child has one candy, and if the child, this child, so this child has one candy, and this child has higher rating. This child has higher rating, so this child must get extra candies. So if the previous child who has the lower rating has one candy, then this child can get extra candy, right? So we'll give one extra candy to this child. Now this child has one candy, but the rating is higher, so this child should get more candies than its neighbor, and its neighbor has two candies. Okay, so we will give extra two candies to this child. Now we'll move up. So the child below has three candies in total, and the current this child has high rating, so this child should get a total of what, 4 candies. So we'll give extra 3 candies to this child. Now this child has same rating as this child, so this child can get only one candy. Okay, now the next child has rating of same as the previous child, so we'll give the single candy. Now this child also has the same rating as the previous child, so we'll give only one candy. Now this child has higher rating, so we'll give one more candy than the previous child, so we'll give one extra candy. So now it has 2 candies in total. Now this child has higher rating, so now this child will have total of 3 candies. This child will have 4 candies, and this child will have 5 candies. Now we are going down. Okay, if we give this child one candy, that will be sufficient. And now this child we can give only one candy more than the previous child. So okay, if this child has one candy, this child should get total of two candies. So now this child has one candies, this will get two candies, this will get three candies, this will get four candies, and this will get five candies. Now going down, this child, this child, this child, they already have one candies. This will get two candies, this will get three candies, this will get four candies, five candies, six candies, seven candies, and eight candies. So initially this child got four candies and this child got five candies. Okay, but if we traverse from the right side, we show that this child got one candy, this will get two candy, this will get three candy. So if this child has lower rating than this child, then this child will get one lower candy, so we assigned one. But this child has high rating, so this will get two candies. Now this will get three candies, this will get four candies, this will get five candies, this will get six candies, this will get seven candies. Now since this child has four candies, this child has seven candies, so this child should get eight candies. So we'll keep the maximum candy here. So condition from the both side will be met. So according to this child, if this child has four candies and this child has higher rating, then this child should get more candies than their neighbors. And what their neighbors has, one of the neighbor has four candies and one of the neighbor has seven candies. So this child should have eight candies. Okay, so when the graph goes up, we can assign a child a candy higher than their previous children. Okay, so for example, if you want to assign candy to this child, then we can assign the candies the previous child has plus one. If the ratings of the childs are same, then we can assign one candy. Now if the graph goes up, then we can assign plus one candies more than their previous child. But what about the graph goes down? So in this case, you see the graph goes up, so we assign 2 3 4 and then 5. And when the graph goes down, we have to start from this position, so we assigned 1, then we assigned 2. Okay, also in this position, if you see, what we did is 2 3 and 4 and then 5, and then finally we'll started from here, 1 2 3 4 5 6 7, and then finally 8 here. So this is how we distributed the minimum candies. So the approach is we'll start from the left in one traversal and then from the right in the second traversal. So this approach will require two traversal of the array. So in the first pass, what we'll do is we'll check only for the graph going upward or with same rating, and in the second pass we'll check from the right side the graph going upwards. Okay, this way. So in the first pass we will assign candies to this child. Okay, this child, this child, this child, and these childs. So in the first pass, what will be the graph? So in the first pass, this child will have one candies, two candies, three candies, four candies, one, 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 and then we have two, three, okay, then four, and then five, and then we will have one, one, two, three, four, and five, and then we will have one, two, three. So in the first pass, we have these graph initialized. Okay, so this one, this one, this one, and this one. So in the first pass, the candies to the children are 1 2 3 4 1 1 1 2 3 4 5 1 2 3 4 and 5. Now in the second pass, we'll travel from the right side. Okay, so we have three candies, that's right, two candies, that's right, one candy, that is right, and then we have this condition. So we have one, so we'll assign two here, we'll assign three here, four here, five here, six here, seven here, and here we already have five candies, but it should be eight candies, because if we assign eight candies, then only the second condition is met, and the second condition is that a child must have higher candies than their neighbors. So one of the neighbor has four candies and one of the neighbor has seven candies. So this child must get eight candies and not five. Then we come here. So we have one candy and then we assign two here, and here it should have three candies, but it already has five candies because one of the neighbor has four candies, one of the neighbor has two candies. There should be five candies and not three. Then we go down, 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 and the traversal is completed. So by traversing from the left and right side, we assigned each position a candy. Then we will take the sum of these candies and finally return the result. So let's see one more example. Okay, so let's see, these are the childs. Okay, so these are the ratings. So initially each child will have one candy. Now, as per the conditions, each child must have at least one candy, and if the child has higher rating than its neighbors, then the child will get more candies than its neighbor. Now, if you see in the graph going upward, if you take any child, for example, this child, so this child has rating higher than the previous child, which means if we assign candies to this child, then the candy to this child must be higher than their previous child. So we don't have to take count of this child. Okay, if we are assigning candies to this child, then we have to take account of only the previous child, because the next child has higher candies. Okay, but this child has higher candies than this child, so we have to take only account of this child. So if this child has one candy, then we assign two candies to this. Okay, now this child, at this child, we know that this child has higher rating than this child and this child. Okay, so we have to take in account both the childrens. So in the first traversal, we will take into account only the left child. So this child has higher rating than this child, but this child has two candies. So this child should have three candies as of now. Okay, but when we travel from the right to the left, we will also take into account this child, because if this child has higher rating than this child and this child, then both child should be taken into consideration. So we have taken into consideration the left child. Now, while going down, we don't do anything, but while going up, this child has one candy. Okay, then this child should have two candies, because this child has higher rating than the previous child, and we don't care about the this child because this child has higher ratings. Okay, now this child has three candies. This child will take into consideration this child and this child. And this child has three candies, right? So this child will have, as of now, four candies. Now let's start from the right side. Okay, so this child should have one candy. This child should have two candies. This child should have three candies. And this child should have four candies, and it is already there. So this child has three candies, this child has three candies, then this child should have more candies than their neighbor. So more candies means we will assign four candies, which is right. Okay, and then we come here, this child has one candies, this child has two candies, and this child should have three candies because their neighbors are two and two, so we'll assign three here. Okay, so that's how this first approach is going to work. So while going upward the graph, we'll take into consideration the previous child only. That's why in the first traversal, we assign more candies to the next child than their previous child. And at the peak point, we'll have to take into consideration both the left and the right child. So while going from the left to right traversal, we'll assign the candies to the graph where the next child has higher rating than their previous child. And while moving from the right toward the left, we'll assign more candies to the next child, that is this child, than this child. So we'll assign more candies this way. Okay. And at the peak point, we already have an assigned candy. Then we will compare the maximum candies of the left and right children and assign that to the peak point. Okay. So now let's got this solution. So let's say total candies we have is 0. Okay, and the size is ratings dot size. Will create a candies array of size n. Initially each child will have one candy, right? Now we'll move from the left toward the right. Is when I is less than n and I plus plus. Now we will check if the rating set I is greater than the rating set I minus 1. In that case, candies to this child is given candies higher than their previous child, right? Now we'll travel from the right side toward the left side. So in I is n minus 2, I is greater than equal to 0, I minus minus. Now if rating set I is greater than rating set I minus, sorry, I plus 1, then candies at I is. Now we'll have to take maximum candies at I plus 1 or candies at I. So why we are using the max here? So let me show you the graph once again. So here you see, so here we have 1, so here we have 2. So we'll take the maximum of candies at I plus 1. So candies at this position plus 1 or candies we already have here. So here we have 1 and when we add 1 it will be 2 or we will take 1. So we will take maximum, that is 2. Now when we come here, okay, so we have 2 here and we add 1 and here we have already 1, so we'll take 3 here. Okay, so we are adding to the previous value, so we have 1, we'll get 2, we'll get 3. But now at this peak position, okay, so we have here 3 candies, we'll add 1. Okay, but we already have here 4, so we'll take here 4 and we'll take maximum out of it. For example, this graph goes down here, so let's say we had 1 candies, 2 candies, 3 candies, 4 candies. Now at this position we have 4 plus 1 and here we already had 4, so we add 4. So now maximum of this will be 5, so we'll add here 5 and not 4. So while going down, we added the condition that if rating set I is greater than rating set I plus 1, but this rating is less than, so we'll ignore this path. So when moving from the left toward right, we'll ignore this path, we'll ignore this path, we'll work on this path and only this path. Okay, so we took the maximum of the candies. Now we'll finally have to return total candies. Now when we are moving from the left toward the right, we assign the candies. Now we are going down. Now one thing is for sure, that we are starting from n minus 2 position, last second position. So at last position, so we can add that using total candies plus equal to candies at last position. Okay, now we'll start from n minus last second position. Now we have to add candies from this position. Total candies is equal to candies at ith position. Okay, so when moving from the right toward the left, we keep on adding the candies. Okay, and we will update the candies only if the graph is going upward from right toward the left. Okay, and finally we'll return the candies. So this is the last position candies, and then we are adding all the candies from n minus 2 towards the 0th position. Okay, now we'll submit this and our solution got accepted. So just to recap, we traversed the array in two passes. In the first pass, from the left toward the right, we assigned candies to the children who has higher rating than their previous childs. Okay, and then in the second pass, we assigned candies to the childs who has higher rating than their next child. Okay, and using these both passes, we assigned candies to all the children, and then finally we return the total candies. Now let's see the second approach. So in this approach, we use extra spaces of n. Okay, and in the next approach we are not going to use any extra space. Now in the previous solution we used extra space to assign the candies. Now total candies, what we have initially, so total candies will have is n. Okay, so each child will have one candy initially. Now let's see, we'll start with the first child. Okay, now while going up, we'll count the peak and valley. Okay, so here each child will have one candy, so we'll not count for those. Okay, so we'll start from here. So this child has higher rating than the previous child because we are going up, so we'll have to give what, one extra candy. So we'll add this one extra candy here. Then we are moving here. Now this child should get two extra candies. Okay, because this child should have more candies than their previous child, and the previous child already has two candies. So this will get 3 candies, which means we have to give 2 extra candies. So we gave 2 extra candies. And this child we have to give 3 extra candies. Okay. Now we are going down. Okay. So while going down, we have to count for the valley. Valley means we are going down. We are not going up now. So if we are going down, then we will give 1 extra candy to this child, and this child we have to give 2 extra candies. Now let's see for this graph only. Okay, so let's see what's the actual graph after assigning the candies. So initially this child has 1 candy, and now it has 1 candy. This child has 2 candies. This child has 3 candies. This child has 4 candies. Okay, and now this child has how many candies? Already has 1. This child has 2 candies. This child has 3 candies. Now let's see in different view. Okay, so let me plot the same graph. So this child has 1, 2, 3, and then we have 4 candies. Now this child has 2 candies and this child has 3 candies. Now these are the total candies. Okay, so we added plus 1, plus 2, then plus 3, then plus 1, and then plus 2, right? So these are plus 1, plus 2, plus 3, then plus 1, and then plus 2. After these peak and valley count, we will reduce minus the minimum of peak and valley. So what's the minimum? So peak was plus 3 and valley was plus 2, right? So minimum is 2, so we'll reduce 2. And now at this point we have total candies for this graph. So let's see why we reduce minus 2 first. Okay, so if you see this, we have 1, 2, 3 and 4 candies, then we have 2 and 3 candies. But it should have been 1, 2, 3, 4, 1 and 2. Right? It should have been like this, right? So if we reduce the minimum, this 2 plus count, we are removing. Okay, so it was essentially remained only plus 1 count. Okay, so we only left with plus 1 count, which means it will be plus 1 and plus 2, so it will become like this. Okay, so we remove 2 candies. So here it had only 2 candies, then it has 3 candies, so we remove 2, which means this will be 1 now and this will be 2 now. And if we reverse this, it will be 1 and 2. So you got it, this will be 1 2 3 4 and then 1 and 2. So these candies are assigned properly to this. So now let's see the next peak. Okay, so now we have here 1. Okay, we are seeing now this graph only. We have counted total candies for this. Okay, now we have 1 here. All these childs have 1, so here we have 1. Now we are going upward, which means peak is 0 here, peak is 0 here. Whenever we are going upward from the fresh, then we'll assign peak as 0 again. Okay, so here peak was 0, here valley was 0, so here peak is 0, so we are going up, plus 1, plus 2, plus 3. We are going down, so plus 1, plus 2, plus 3, plus 4, plus 5. So let me draw this graph once again. So we have plus 1, plus 2, plus 3, and then we have plus 1, plus 2, plus 3, plus 4 and plus 5. Okay, so the candies will be 1, 2 candies, 3 candies. This will get 4 candies. This will get 2 candies, 3 candies, 4 candies, 5 candies and 6 candies. So we counted all these candies. Now we will reduce the minimum of peak plus 3 and value was peak of 5. So we'll reduce 3 minimum. So we reduce 3. So if we reduce 3, this will be gone. Okay. And now it will be like this is plus 1, right? So we'll shift this up. So it will be plus 1 here, plus 2 here, plus 3 here, plus 4 here, and plus 5 here. Something like this, right? This will shift upward. So it will be like 1 here, 2 here, 3 here, 4 here, and 5 here, and then 6 here. Got it? So we reduce this peak value and these elements shift up. So this way we counted all the candies this graph will have. Now let's see one more example to understand this better. and then we go down. So in this case we have 3 childs and 4 5 downwards, let's say. So when we are going up, we'll add +1, we'll add +2. When we are going down, we'll add +1, +2, +3, +4. So now the child will have total candies of this child will have 1 candy, this will have 2 candies, this will have 3 candies. And now this child will have 2 candies, this child will have 3 candies, 4 candies, and 5 candies. Now you see that we have added +1 candies for each child. So we'll have 1, 2, 3, 4, 5, 6, 7. 7 candies we already have. Now we added +1 and +2. So we have +1, +2, then we have +1, +2, +3, +4. Okay. So we have added these candies. But now you see, for this peak value, here we added +1, +2, +3, +4. But it should have been like this. It should have been here. This child has already 1 candy. So this will have +1 candy. This should have +2 and this should have +3. And here we'll check for this child and this child. So in general, it should have 1 candy, it should have 2 candy, it should have 3 candy, it should have 4 candy, and this child should have 5 candies. So this should be our arrangement and not like this. So in this arrangement, we have counted duplicate candies. So we'll check the minimum peak and value. So the peak here was +2 and the peak here was +4. Minimum was 2, which means we have to remove this. So if we remove this 2, so if we remove this and if we reverse this graph, so this will be like +1, and if we reverse this 1 will come here. So 1, then this +1, this +1 means +1, then +2, then +3, and then this +4, right? So this will be nothing but like this: 1 +1 +2 +3 +4, 1 +1, like this, right? This will be 1, 2, 3, 4, and 5 candies, 1 candy and 2 candy. So this will become like this, which is right. So in this case, we removed the peak. Now let's see one more example. So here we have +1, +2, +3. Here we have +4. Here we will have +1, we'll have +2, and +3. So we have total of 1, 2, 3, 4, 5, 6, 7, and 8 candies we already have. Then we added +1, +2, +3, +4. And here we added +1, +2, and +3. Now it should have been like this. So this is 1 candy, this is 2 candy, this is 3 candies, this is 4 candies, this is 5 candies, and then this should be 1, this should be 2, and this should be 3. And these 5 candies are okay because neighbors are 4 and 3. So these are fine. Okay. Now let's see. So we'll take the minimum of peak and valley. So peak was +4 and valley was +3. So we'll remove +3. And if we remove this +3, what will happen? You can see if you remove this is what the graph will look like. So this will be 1 +1 +1 +2 +3 +4, and this will be nothing means +0. So this is 1 candy, and then this is +1 and +2. So this will be +1 here and this will +2 here. So this is 1 candy already, this is 2 candy, this is 3 candy, and this is +4, 4 candies. So which is the correct combination? Now let's see one more example. So this is case of peak and this is the valley. So in case of peak, we are moving upward. So we keep on adding, for example, +1, +2, +3, and +4 here, for example. And while going down, we keep on adding. Okay. So here we have +1, +2, +3, +4, and +5. Now, if you see the correct result, it should have been +1, +2, +3. Okay, and +4. So this is the correct order. Okay, and from bottom it should have been +1. Sorry, here it is already 1 candy, so it will be +1 here, +1 from here only. Then we should have +2, then we should have +3, then we should have +4, and here we should have +5. Which one will be higher? We should pick this one and not this one. Okay, so the correct order should have been 1, 2, 3, 4, and 5. But what we have plus 1, we have here plus 4, we have here plus 1, we have plus 2, we have plus 3, we have plus 4, and we have plus 5. But it should have been like this, right? So if we remove this plus 4, what we will have? This plus 5 is here now, right? And these values will be from here, plus 1, plus 2, plus 3, and plus 4. So this plus 1, plus 2, plus 3, and plus 4. Now I think you will be able to get why we were removing the peak and the valley's minimum value. Okay, so when moving from left to right, we had plus 4 here. When moving from the right toward the left, we should be having plus 5 here. So we had plus 1, plus 2, plus 3, plus 4, plus 5. If we reverse this, it will be plus 5, plus 4, plus 3, plus 2, plus 1. Okay, so it should be this. So here we will be having plus 5, but it's already plus 4 here. So in the total candies, we counted plus 4, and we are now counting plus 5 also. So one should be removed, right? So we will remove this plus 4, minimum of these two. So this was what? Peak, and this was valley, and the minimum is plus 4. So we will remove plus 4, and plus 5 will take this place, and finally we will have plus 1 here, plus 2 here, plus 3 here, plus 4 here. Actually, when we were moving down, we were increasing the plus 1, plus 2, plus 3, plus 4, plus 5. This plus 5 came here, and these values will be like this: plus 1, plus 2, plus 3, plus 4, and this value will be 1. Okay, so now let's code this algorithm. Okay, so we have total candies as initially n. Okay, and we'll move this up. So now we'll start with the first while this I is less than n. One more thing, when the ratings are same, the candies for those children who has the same neighbors with same rating, they will get only one candy, right? So the first thing is, if the rating set I is same as rating as previous children, then we will do nothing. Okay, we'll just increment the I and continue for the next iteration. Now if the graph is going upward, we'll have to count for the peak. So peak is initially 0. Now while I is less than n and rating set I is greater than rating set I minus 1, so the graph is going upward. In that case, we'll increment peak plus 1 plus 2 we were doing in that graph. So this is plus 1 plus 2, and we will count these candies also. Total candies will be equal to peak, and we'll increment the I also. Now for the downward graph, we'll count the valleys. When we go down, we have these valleys. Okay, so if I is less than n and rating set I is less than rating set I minus 1, so in this case we'll increase the valley. We'll count into total candies plus equal to valley, and we'll increment the I. So we counted the total candies. Okay, and while going down we also counted the total candies. So here in this case, so the peak was plus 4. Here peak was plus 4. So we counted this inside total candies. And while going down, we had plus 1, plus 2, plus 3, plus 4, and plus 5. Okay, so this plus 5, if we reverse this, it will be here plus 0, means the one candy it already has, so it will be 1 only. So we'll start plus 1 from here, plus 1 from here. So plus 2, plus 3, plus 4. So this will be plus 5. So we'll have to keep only one, either plus 4 or plus 5. So we'll keep plus 5 because it satisfies the second condition, that it has higher candies than their left and right. So left has 3 candies, and this will have plus 4 plus 1, that is 5, and plus 5 will be 6 candies here. Okay, so we'll keep the plus 5 and not plus 4. So finally, from total candies we'll subtract minimum of peak and valley, and finally we'll return the total candies. So let's see. Okay, so our initial test case has been passed, and now we will submit this. And our solution got accepted. So just to recap, so when we were moving upwards, we'll increment the peak values and then add this inside the total candies. So initially we have n candies, and now we are adding only the extra candies. So when we are moving upside, we'll give extra candy to these childs, okay, and then we will add those extra candies. So for example, to the first child we will give plus 1 candy, then to the second child we'll give extra 2 candies, then third child plus 3, fourth child plus 4, only when we were going upwards. Now for at the peak, we'll give extra these peak amounts of candies. Now we were going downwards. Now when we go down, we'll increase the value and include those inside the total candies. And finally, we'll reduce the either peak or valley. Okay, so we'll have to keep either the peak value or we'll have to keep either the valley's maximum value and remove the minimum value because they are adding the duplicate candies. Okay, so we removed the minimum of peak and valley, and finally we'll return the total candies. So that's it.